about the opportunity it gives to students, how it is essentially introduction to research level work that students would do for the first time in their lives. So let's begin. My name, Avi Banergee. I grew up in Hong Kong. I went to South Island School, and I also did the IB. From the years 2012 to 2014, I participated in the IB. I did the IB. I took HL Mathematics and HL Physics. After that, I went to the UK to study, to get my integrated master's in mechanical engineering from Imperial College London. And I'm back in Hong Kong to teach maths and physics. So, enough about me. Let's get straight to the beginning. So essentially, if we were to take a more broader look at what the IAs are, we must understand that it's the coursework element that we have that in our course. For certain subjects, it could be as much as 50%. For other subjects, more like 20%. For maths and physics, it's like 20%. What a key expectation that the International Baccalaureate has, the program has, is that students are expected to go beyond their comfort levels, right? Go beyond the syllabus that they've been taught in school. Obviously, it's quite a broad syllabus. You'll still be loosely associated with the syllabus, but go the extra mile, as they say. Do a little bit more, show your enthusiasm, show your research capabilities, and above all, show your independent learning, your research work, right? So, before we begin, a disclaimer. The tables and the grading systems that we have been taken directly from the IBO website. My theory is you don't want to hear what my opinion on how to make a good IA is. It should be what the IBO says. And it's my job to interpret that information and give you a better understanding. Okay? So the tables that you'll see are directly from the IBO website. Now, let's begin with mathematics, right? Most of the times when you associate maths in school, you don't normally think of as an exciting, riveting subject, do you? No, you normally think boring graphs and equations. Well, the IA provides you a good opportunity to go beyond the extra mile, as they say, right? Increase your personal engagement. Improve your understanding of key concepts. So, in the words of the IA, the individual and it is an exploration, by the way, that is what they call it. They don't call it an IA. The individual exploration is a piece of written work that involves investigating on an area of mathematics, There are 5 criteria: communication, mathematical presentation, personal engagement, reflection, and use of mathematics. So before we go forward, let me get you an example IA, shall we? Ooh, not there. Hold on. Mathematics IA. Yeah, there it is. So this is obviously a good student, right? Because he has gotten 18 out of 20 in the IA. That's a pretty good score. So let's see what the IA looks like, right? This is a model of success, as they say. It's loading. Okay, as it loads, let's get back to our presentation. So, communication. Again, you might think, communication must be restricted to a English assignment or a history assignment or a philosophy assignment. Well, maths is all about communicating, right? It's about communicating your understanding, your theories, how to show a logical progression from one step to the other using mathematical concepts and data. So hopefully, and if you go to the edge, you definitely will, you'll get the highest number of marks, so 4 marks for your communications. And to do that, you must have a coherent, well-organized, concise, and complete process, right? You can't have steps missing. You can't have an illogical way of thinking. You must follow clear mathematical principles. Okay? Now let's see what this model student has done. So this person's IA was titled, "What is the relationship between maximum thickness of an airfoil and the lift force generated by it. By the way, it's no accident that I chose this subject. In fact, in my master's year, I studied about lift force and things like that, because my main master's level subject was aircraft engine design. It's another reason why you guys should study engineering. Provides you with cool opportunities to express mathematical and scientific ideas. So let's see the beginning, shall we? Well, it's clear. There's a good introduction. This, as the comment says, the introduction is clear and an explicit description is given. Right? It's not a two-page theory. It's just a couple of paragraphs detailing what they want to talk about. Right? The topic is of significance because there have been large amounts of literature in the angle of attack and the lift force generated, but not necessarily on the thickness of the airfoil. That provides a purpose of doing this investigation. Automatically, I know why this student has chosen this project. Okay, so that's what I mean of being concise. Now we'll get back to this. Let's get back to our presentation, shall we? So the second thing that we have been told is mathematical presentation. This requires you'll get maximum 3 marks. Again, go to the edge and you'll get your full 3 marks. So here it's the idea of using mathematical symbols, terminology, notation. During this IA, you'll probably have multiple 10s, 20, 30 different equations. It's important to label them. Call that equation 1, call that equation 2, using a scientific and mathematical approach, as they say. It'll help you think as a scientist, as a mathematician. Now, as it says, there's going to be different formulas, different tables. It's good to use a good variety, show that you have a good understanding of a wider range of mathematics. So let's see what they say, how to get the top 3 marks. The mathematical presentation is appropriate throughout. You aren't using GCSE level charts and tables. You aren't using kindergarten level, or maybe that's being a bit too harsh. You aren't using primary school. You're using IB level, which is as close to university level as you'll get, sometimes even as high as university level, right? So it's the level of detail. So if you have graphs, you'll have to do uncertainty analysis. If you're doing charts or graphs, graphs do normal distribution, right? Instead of just having bar graphs, which could be useful, but normal distribution is a good way to highlight mean and the relationship with variance, right? You'll see the 80% uncertainty. You'll get the bell curve. Those are good instances of where you can use complex mathematical principle that you've learned in school, learned part of your IB diploma, and incorporate that into your exploration. By the way, I forgot to stress this earlier. Whilst the IB course has changed in regards to mathematics, this will be the final year where we have the traditional further maths, higher maths, standard level, and studies level. Moving on from next year, there'll be 2 maths courses, in fact, and both will have a higher level and a standard level option. Okay, whilst that has been a significant change, the IAs are still going to be as it is. It's still going to be this structure. Okay, so don't think that this information that I'm providing is only limited to this exam cycle. All right. Okay, so moving on. Personal engagement. Now, let's look at the previous example, the model example as I had about the airfoil. We'll go back to that after I've gone through the different. The student is interested about aviation, is interested about aircraft design. So clearly there is a personal engagement. He's showing why he's interested into this. And this is important. Look, even though these are internally assessed, and they will be moderated. Some people from each class, they will have to submit their final product, final exploration to the IBO to see if the grades that the school is given are appropriate. And depending on how the IBO thinks the school's grading is, everyone else's grade will be affected. So the IBO doesn't know you. The person who, if your work gets moderated, has never met you. Your teacher might know you. Your teacher might know why you're interested in a certain subject, certain aspect of mathematics. But the guy who, if your work gets moderated, he's never met you. So it's good to show your personal engagement clearly, right? It's no point saying, well, everyone knows that I like planes. That's why I wanted to talk about airplanes. No, you have to show it. You have to show that there's a personal engagement. As they say, to get the highest level of achievement, 4 marks again, there must be an abundant evidence of outstanding personal engagement. Okay? Moving on. Reflection. Now, whilst in my opinion, this is probably the hardest aspect of any IA. We'll see more so in the physics element, but definitely in the maths IA as well. Because when you're very involved in any piece of work, it's hard to take a step back and see, wait, the data I have, the analysis that I have, is it appropriate? Is it enough? What's lacking? How can I improve on this? How can this exploration be expanded? Okay, let me quote directly from the IBO. It says, assesses how student reviews and analyzes and evaluates the exploration. Although the reflection may be seen in the conclusion of the exploration, it may also be found throughout the exploration. And in fact, that's a good point. Normally, I as a teacher, during my student days, I actually thought it's a bit of a cop-out to have all of the reflection, as they say, at the end. No, you should have reflection throughout the process. Every time you do a step, every time you have a piece of data, every time you go through one new mathematical concept, you must be evaluating it. What are the strengths and weaknesses of each method? Say we're looking at statistics. What's the strengths and weaknesses of a normal distribution? In fact, are there instances where a normal distribution isn't even appropriate, where it doesn't follow a bell curve, might follow a dual bell curve, right, with 2 different peaks, right? So these are the things that we must be mindful throughout the IA, and I think that's how you'd get the top 3 marks needed. Now, finally, the lion's share, the meat of the coconut, as they say. It's the use of mathematics. Now, let me address the higher level aspect of it, okay? Because most of our students are higher level students, but even those who are taking standard level, this is still important. It's still the same number of marks. It's just a bit more rigorous demands that you must achieve, okay? So, again, hopefully everyone will be getting 6, and if you come to the edge, you'll definitely be getting 6. So, to get those 6 marks, you need to show relevant mathematics that we just commiserate with the level of the course, right? You don't want to be using things that are from GCSE level. If you're going to use statistics, probability, go over and beyond, right? Show more understanding. If your project is on calculus, go beyond simple calculus principles that you've taught, right? That you've been taught. Go in greater detail. In fact, this is a great opportunity for students, and people who do take higher level maths courses will end up going into similar programs in university. This is a great opportunity for you to look at university level textbooks. What are university courses like? What sort of mathematical principles are they teaching? Because it's ultimately step by step by step. What you do in IB will be useful when you go into the to university level courses, right? Now, finally, it says that the mathematics explored is precise, reflects sophistication, and rigor is expected. This is the fundamental point. You must show that it wasn't easy. I'm sure it wasn't easy, because if you're taking HL maths, you clearly have a passion. You don't want to do something easy. You want to challenge yourself, right? And you must show thorough knowledge and understanding, right? You must show that you understand what you're doing. No point, if you're my student, I wouldn't do your exploration for you, right? It'll be a collaboration. You will have to create the idea. I will, obviously, if I was your teacher, and anyone who teaches in Edge will definitely do this, they'll help you throughout the way. They'll give you steps, they'll give you pointers. But ultimately, the IA has to be you, and you must understand it. We, as teachers, will always help you understand it, but you have to demonstrate it. So yeah, let's summarize the use of mathematics. Okay, so the work must be commensurate with the level of the course. Mathematics should be either part of the syllabus, but to get the greater grades, you have to show some level beyond the syllabus. It should not be completely based on mathematics listed on prior knowledge. Of course, you will use some prior knowledge, but as I said, must be new knowledge. New knowledge, that is a funny term. Like, knowledge exists, but new knowledge for you, that is. And mathematics that can be regarded as correct. By the way, this is an important point. Even if you have a couple of errors, which, again, come to the edge, we'll fix those errors, so you won't get those errors. But even if you do have a bit of errors, that is not the point. The point is, what's the process? It's just like your any IB exam. You can easily get a high grade by having one or two mistakes, so long as it shows logical thinking and hasn't corrupted or affected the rest of your project, right? You must show sophistication in challenging yourself in different mathematical concepts. And as I said, you must show rigor, logic, and the language used must flow, right? It can't look random. You must have a level of accuracy. Now, before we move on to the physics, let's go back to what our ideal example is. So, remember how we had talked about there must be clear demonstration of clear communication? Well, let's look at this diagram, shall we? Do you see how he has used color-coded text to highlight the upper streamline and the lower streamline? That is an effective tool, isn't it? When I, as the viewer, I as the teacher, I as the marker, when I see it, that makes sense. Like, it clearly separates the two different flow processes, right? Now, one thing I will say this student could have done better is label each equation, right? They've said, let's look at this line, shall we? Let's combine the two equations. Well, which two equations? Should it be what I would do is, let's combine equation 1 and equation 2. And I would have earlier stated which are equation 1 and equation 2, right? All in all, this was a great IA. If you go through the rest of the IA, you'll see there's some clear, sophisticated mathematical principles. He has used integration, which is part of the course, but he is this person has incorporated that level of mathematics into a real life application, which is vital, which shows that, look, it's not, mathematics isn't just equations in a piece of paper. There are real life applications. Now, as I'm going through this, I can see some other mistakes, by the way. So I should have actually highlighted this earlier. In fact, it's okay not to have a title page, but having a title page is good. It separates the work, or it clears it up a little bit. But importantly, the next page, you should have a contents page, right? So it provides a structure to the report. Not that this report doesn't have structure, but to any outside reader, he would know, okay, first I'm going to read this, then I'm going to read that, then I'm going to read this. Okay? After the end of my lecture, if you want me to discuss this IA specifically a little bit more, I'd be happy to do so. It's a topic that I have a lot of interest in, and who knows, maybe if we have the time, I could even explain how this sort of knowledge is very vital in us understanding why planes crash. We saw recently with the Boeing 747 MAX 8, them being suspended, how it's actually, whilst it being a very complicated issue, at the heart, it's quite a very simple physics problem, which is very related to the topic in this IA. Okay, so before I get back here, let's get back to no, not here. Let's get back to our PowerPoint presentation, and let me see if you can see me again. Yes. So the physics exploration, again, now this is where there's been a bit of change. So they changed it in the people doing the exam from 2015 onwards. Okay, that the 15 or 16, that the physics exploration is now more independent. It's like the Maths IA. It's not this. Ooh, this is embarrassing. Simulation. Yeah. Okay. So the physics exploration used to be you do a lab in class and then you do a lab report. There is still an important element of note taking and data collecting, data reporting, but it's a lot more independent. It's up to you. So the 5 criteria are personal engagement, exploration, communication, analysis, and evaluation. Okay? Now, this is what I was talking about earlier. There could be physics a bit more broader than mathematics. So there could be like 3 forms of IA. You could have like the old traditional style, hands-on, practical, and you do your experiment, you collect your data, and you report it. Perfectly fine. It's good. Another one is database. We'll see actually a couple of examples where how these 3 different IAs work. And the other one is simulation or modeling, right? Again, we'll see an example from those 3. So by the way, again, a disclaimer, I haven't created any of the information in the following tables. Again, we rather get it from the horse's mouth. It's the IBO who's provided us with the tables on how the IAs will be marked. Okay. Now, before we go forward, let me see if I can get these are different physics IAs. Okay, as you can see, they've been provided to us from the IBO. So as I was saying, you can have a hands-on practical, right, experiment. In this one, this student was on determining the charge of an electron using computer simulation. Sorry, this is a simulation or modeling. It's in the title, my error. Or you could have investigating properties of light-dependent resistors. This is actually quite a core part of the course, the theory behind it. So if you're going to do an experiment, do that experiment and report on it. Give your feedback, okay? And in terms of database, an example here is determining the circumstellar habitable zones of the 5 stars. This is a fancy way of saying investigating the Goldilocks zone. You know, we have all heard the tale of Goldilocks about having a porridge not too hot or not too cold, just right. Well, each planet has that sort of zone, right? Where life can exist. Earth exists in the Goldilocks zone of the sun. This is a sort of IA where students won't be able to get independent, fresh data by themselves, right? We just don't have that equipment in schools. So you do have to depend on databases, but you can still do fantastic analyses. It incorporates the astrophysics option within the IB course. We can look at each of these IAs in detail. But before we do so, let's see how these things are marked again. Okay? So back to our PowerPoint presentation. So personal engagement. Again, similar with the Maths IA, you have to show that you're interested into this, right? And look, this might be quite difficult, I understand, because obviously if you're taking physics,
you have interest. Your physics HR is one of the more difficult things you can take. So obviously you're interested. And your private tutor or any teacher on the edge will know that you have
an interest in this. Your class teacher who's seen you for years will know you have an interest in this. But it's the act of communicating that to a third party and the audience, right? Imagine if yours is the one that gets moderated and sent to the IBO. So again, if you're coming to the edge, you will be getting, it will not take anything less as an answer. You'll be getting the highest marks possible, and hopefully you'll get 2 marks for the personal engagement. So what is it that the IBO says that they think that you need to show? Well, it says that you have to show evidence of personal engagement with the exploration, that it's clear and significant independent thinking, initiative, or creativity. It is hard, I understand, but I'm sure with our help, the school's help, together we can find the perfect topic for you. Okay? Now you have to give a justification, right? You have to show, and it has to be believable. So perhaps, I don't know, maybe this might be controversial. Tell the truth. Choose a topic that you do have interest in. Justify it. Why did you choose it? What was your personal significance to it? What interest did you have? What drove your curiosity, right? And finally, there must be evidence of personal input and initiative, right, in designing, implementing, or the presentation of the investigation, because ultimately this is independent learning, right? You don't want to just do what like the textbook says or your teacher might have said. You want to show, because your teacher will be the one who initially gives you the mark. You want to show that you have put some personal input. You've thought outside the box. You've read what university or higher level physics studies have done, right? That in itself is initiative. No one is asking you to come up with a novel way of finding a scientific principle. You're not there yet, but it's the initiative that we want, right? Okay, let's go to the next bit. By the way, as we said, it's no longer called the IAs. They're called the physics explorations, the maths explorations. It's a more fitting description of what it is, because it shows the sheer breadth of the requirements that that you have for these projects, right? It is quite a difficult thing that the IBO is asking you to do. They're asking you to go to new knowledge that you haven't seen before, or discover new knowledge, right? That obviously exists. You haven't come across that as a student. So finally, again, if you come to the edge, hopefully we can help you get the 5 to 6 marks required, the highest grade boundary. And for that, you need to show that the topic of investigation is identified as a relevant, fully focused research question. It's clearly described. No point having a vague answer. Have a clear, concise answer. We saw the one about we saw the previous examples. What's the relationship between temperature and diodes, right? Isn't that what we saw? Let me just get back. Investigating the properties of light-dependent resistors, right? That's quite a clear description of what they want to investigate, right? Anyways, let's move on. The background information provided for the investigation is entirely appropriate and relevant, and enhances the understanding of the context of the background of the investigation. Look, take the one about the Goldilocks zone, about the different planets, right? Which one was it? Determining the circumstellar habitable zones of 5 stars. I'm sure this, in fact, we can just look at it. What does it say? Hold on. Investigating light. Nope. This one. Yep. Let's see what the annotated student work is. Hopefully this was a good project. I like it already. Has a good presentation. You see, as you can see, it's even the teacher's comment is one of the more interesting comments that they have done. And by the way, this student did earn one of the top grades for personal engagement, as it's written. Okay, as this is loading, let's get back to our presentation. Okay, so the methodology for the investigation, by the way, must be appropriate. You can't have random things compiled together. You must follow the scientific method. You must ask a question, state your hypotheses, and test it out. Do the experiment. Follow a logical progression. And the report shows evidence of full awareness of the significant safety and ethical environmental issues. Again, so let's take the aspect of the planetary study investigating the Goldilocks zones of different stars. There are ethical elements, right? Because a lot of the data that we have collected are from satellites. The ethical aspect to this is, to what extent is it appropriate for governments and agencies to spend money on space research when there's a lot of other problems on Earth already, like poverty and hunger and disease, right? This relates back to the background information, the context behind the study. Why is there a need to study the different Goldilocks zones of different stars, right? Of orbits around different stars. Well, one, it does go back to the space race from the 1960s. Space race was a great period of scientific achievement in the 1960s that resulted in the moon landings in 1969. The accumulation of a multi-billion-dollar science project, essentially. But the context behind that study could be: look, we want to be a multi-planetary species. We don't want to, with climate change and future calamities, we don't want to be short-sighted. We should plan ahead. Not that I agree with this, not that I think that this is a pressing concern, but there were legitimate reasons for this investigation. There is a background information, right? There is a context behind it. That's what is vital that you have to express. Finally, okay, so we've talked about exploration. There should be two more. Analysis and evaluation. Okay, so the student's report does not reach a standard described by the, we don't want to go there. We want to have a great mark for evaluation. By the way, this is similar to the maths section, where evaluation tends to be the place where students get the lowest grade. Okay? So again, if you come to the edge, don't want to brag here, but we'll help you get the 5 to 6 marks. Okay? So the detailed conclusion is described, it's justified, and it's entirely relevant to the research question, is fully supported by data presented. Scientists do not go jump to conclusion on whims or on feelings. You have to show strong data. But as you collect data, let's take the example of the diodes or the resistors. Let's get back. Hold on. Which one was it? Light-dependent resistors, right? You have to show the data collection, right? What was the uncertainty analysis? Do some uncertainty analysis. That's part of your evaluation, right? How strong is your data? Is your data reliable? What are the strengths and weaknesses of your data, right? So again, evaluation should not be done in one last little paragraph or a last little page saying evaluation. No, you should be evaluating your data, your process throughout, right? Ultimately, you need a conclusion. Does it match? If you had a hypothesis, if it was an experimental sort of data, did it match your hypotheses? If not, how could it be improved? One of my colleagues was telling me the other day that they had a student who was investigating soundproofing, right? Was investigating how would styrofoam, how effective is styrofoam in canceling out sound. Turns out the hypothesis was, with using thick styrofoams, the one wouldn't be able to hear the sound if one screams through it, and their face is covered in styrofoam. But turns out no, the sensors did read the sound readings, and then that didn't match the hypotheses. But then why didn't it match the hypothesis? Then we found out, styrofoams do have a bright white color. They maybe are reflecting. What if we painted them black? And that provided results which were more in line with hypotheses. But just because the original set of results didn't match your hypotheses didn't mean they were useless. They were pretty important. In fact, the next time, say this was in a published scientific paper, there's no such thing as bad data. It could be, so long as you understand why that data doesn't match your hypothesis or doesn't match the theory, it helps other scientists to prevent doing the same mistakes again. What else? The student has discussed realistic and relevant suggestions for improvements and extension of the investigation. That's a good point. A key element is you want to show that you are a scientist at heart. That's what the IBO is looking for. And you won't have time to do research that is full, final, end of it. Science never ends. Science always moves forwards. Take the one about finding the Goldilocks zone. How, after this person's done his report, how could this report be expanded? Of course it can be expanded. What other information is required? What more do we want to know? What more how can we find more information, right? Okay. The use of mathematics, the way the report is well structured and clear. Actually, this should be structure. fact, presentation, fact. Right? My bad. It shouldn't be. What do you call it? It shouldn't be mathematical methods. It should be probably. I think we're done actually. Yeah, presentation. Yeah. So these are the final 4 marks you need for the presentation. Again, hopefully all of us will be getting the 4 marks. The presentation of the investigation needs to be clear. When you have errors, or when you're publishing a report, make sure you have a spell check. Make sure your grammar is correct. Make sure that it follows a logical progression. You don't skip steps. You don't have random things stuck in just because you think is correct. If you do have any errors, make sure that those errors are analyzed within the uncertainty analysis. All of these are the things that you need to get the 3 to 4 marks. Okay. Good luck. But before we end, let me just go through the physics IAs, shall we? Where are the physics IAs? The example ones. Yep, this is the one about this is the one regarding simulation. This is the one regarding light-dependent resistors. In the meantime, we should have access. Yep, this is the one we were talking about earlier, finding the Goldilocks zone. Okay, so by the way, this student follows a clear presentation, right? As in the first thing should be, hey, what is this report about, right? Sure, you do have a titles page, but the title page is too vague. It's the research question. What is it that you're investigating? As you can see, the thing I've been highlighting all along, the Goldilocks zone is another term people use. What is this person investigating, right? What is the report about? This person holds the hypothesis that the findings of the study are that higher class stars will have a CHZ further from its surface. However, the range of every CHZ again, the Goldilocks zone, will remain relatively constant throughout all star classes. Now, that's this person's hypothesis. This hypothesis would ordinarily come from having studied the astrophysics options module within the IB program, right? But just look at the way this process is laid out. It's very clear. Look, the selection of stars. Which stars did you choose? Again, the thing that you need to cut out from any report is the randomness. This person hasn't been random. He has chosen specific stars for specific reasons. The stars that this person has chosen are within 10 light years away. By the way, I'm sure you all know light years is not a unit for time, it's a unit for distance. It's if light travels at the speed of light for 1 year, that's called a light year. For those who are just entering IB who aren't familiar, that's an interesting piece of information. Okay, and the other way that this person chose and selected stars is by the luminosity of the star, right? How bright it is. And these aspects were discussed later, but the brightness of the star is very much correlated to the magnitude, the size of the star. And look what this person did. We all know this relationship between luminosity, right? We have used this relationship within the IB course, but you don't want to be sticking in equations for the sake of it or just because you think they're relevant. As the comment from the teacher says, that this relationship has not been used in the investigation. So whilst it could be relevant, and whilst it probably is relevant, and whilst it is from the IB course, no point sticking it in. That's just taking up space, but above all, distracting the reader, right? Distracting the reader from a logical process where you've just put something in but never used. So anyways, I won't go through the entire report, but this report, despite that little mistake, is still amazing. It's still very clear, very well organized, right? It's not messy. You can see they followed mathematical equations. They go step by step, and wherever there are important pieces of information or conclusions, this person is bolded. Perfectly fine. If you want things to stick out, make it stick out. Okay. Okay, this is the other IA, a most appropriate investigation, but the second research question should have been addressed. Okay, so This is where teachers like me can help, right? Where if you do have secondary research questions, we don't want you to just have the secondary research question just because you think it might look good. You really need to address it. You need to incorporate it in. Okay, more than enough background information. Yeah, this person has written quite a lot, but I'll tell you one thing that I really do like about this person's report, which shows a level of understanding and sophistication that you get from university level project, is the citation. Look at the citation. That's a professional level citation. Don't forget, part of being a good scientist isn't claiming that you know everything. No, part of being a good scientist is understanding what you don't know and acknowledging, look, we are all in the steps of giants, right? We are all walking in the same road the way we're going, we could not have gone this far had it not been for the scientists of yesteryears. Okay? So there are problems with this, clearly, as we can see from the teacher's comments. The only source found, not much initiative with this attitude. Exactly. Again, you want to show good you want to show that you're enthusiastic about this project. The very fact that the student has said the only source found regarding the area of the sense, well, there are things like this. There are lots of sources, right? You finding only one source does reflect a level of I don't want to say laziness, but not the right initiative. Okay. But clearly, even a good report, there's some problems with it. Look, the variables have been, since this is an experimental report, it's important to list out the independent variables, right? The control variables. This person has clearly done that. Very well done for an experimental project. Okay? Since it is an experiment, not a simulation, not from databases, this person has used has highlighted the method, the apparatus used, most importantly, by the way, a model, and what the experiment looks like. But there can be sometimes when you go a bit extreme, when you go into too much detail, right? Look, 6 wires, 2 crocodile clips. You don't need to tell me that. If you say wires, good enough. Okay, this is too much information, but it's okay. It's still focused. It's still relevant. You're giving me too much information, but it's not information that isn't outside the realm. Okay, and look, this is what we talked about earlier. What are the risk assessments? This person's clearly shown awareness to safety. When you do experiments, there are safety elements, right? Especially when you're dealing with electrical components. You don't want to be near water. You want to have a safe working unit. This person's thought of it. Okay. This has been all in all a good experiment. There's some good data. They've done multiple trials. They've done multiple trials to get a better average, higher quality data, right? By the way, you can see that there's a student error here. Anyways, finally, let's move on to the final one. This is the one regarding computer simulation. What does it say? The personal engagement is assessed holistically at the time and effort the student put into the investigation. The clear understanding and insight demonstrated, the detailed analysis all add up to full marks for personal engagement. Okay, this person did pretty well. Again, look, he has the research question. He's highlighted it. Nicely stated. But one method alone would have been acceptable. So you see, this person went over and beyond. He did multiple methods. One thing I do like about it is he has the historical background. He has shown, like, him having the historical background adds to his personal story on why he chose that topic, right? Doesn't seem random. There is a wide interest in the scientific field to study about this, right? It's not frowned upon. Okay. It's actually quite good that this person has acknowledged the previous scientific work that's been done on it. Okay, again, good citations done. This person has a methodology done. It's a pretty detailed experiment described. it's a pretty well structured report, isn't it? Very well detailed. So as we're coming to the end of this session, again, the method is written. He's done, as we said earlier, multiple experiments, multiple simulations. Sorry, shouldn't say experiments, but he's done multiple methods here. It's a very well structured report. The main point on showing you all three of them were you could have a good physics IA on a wide variety. You don't have to have a simulation or modeling like the previous student. You could do something on something very out there, something that you wouldn't normally think a science, high school science student should be or would be working on, like finding the Goldilocks zone of different planets. Or it could even be basic scientific experiments that you do in class, like light-dependent resistors, but expand upon it, get new knowledge, show a better understanding, and above all, report your data honestly. So, as we end, all I'll say is good luck, and if you do have any questions, do leave them in the Q&As in the comment section, okay? And I will try to answer them. So, let me go back to the physics page. Sorry, Mandy Fong. That is, I'm sorry to hear that the sound was too loud and you couldn't see the PowerPoint clearly. I will definitely give you the PowerPoint. In fact, let me attach the PowerPoint now. So let me save it first. Insert, hold on. Okay, I'm finding it now, but let's try it now. Okay, I'm finding it difficult, but we will get back to you with sending you the PowerPoint. Okay? Let's end the live session, and if there's any more questions, you can contact the Edge.